So another way to look at this proof of correctness is by thinking, what could go wrong? So clearly we need to include AI, so the only thing that could go wrong is in this part. What if the recursion fairy gives us a j for a I plus 1 through j that isn't the best j for ai through j? What would this mean? Well, intuitively, the only difference is it's saying adding AI offsets the badness of adding a j plus 1 to a I plus 1 through j. So the idea here is if you had this array, and let's say this was I, maybe this is a really good value like 40, you have I plus 1, and it goes to some j, and then j plus 1 wasn't included. So the only reason j plus 1 would not have been included is if it was negative. So this is some negative number, and so it doesn't benefit the recursion fairy to include it. And not only that, but everything that comes after also isn't that big. Because if it was big enough, then the recursion fairy would have justified it, including j plus 1. So there's no point in going beyond j. Now we've added I. Now that we've added I, does it make sense to include j plus 1? Well, no. Why would it? It's still negative. It's still not really helping us. So even though we might have increased our sum by adding AI, it doesn't mean that we can increase it even more by now adding bad things to it. There's just no point. And even worse, I could have been -5 or -6, and then it's definitely not helping. Adding AI didn't help, and so certainly it won't help to add other bad stuff. So that's another way to see why the proof of correctness holds.